Alright guys, I think I actually fixed the lag in the chat. It should be a lot better than 30 to 40 seconds like it's been. I got tips from a 12-year-old off of YouTube on how to fix it, so we'll see if it works. What's up, Chris? I've really been kicking around the idea of making a video explaining the math behind pool. Kind of sucks the pool halls are closed because I ain't got nothing to do. I'm so bored. I'm trying to figure out, like, what would I want to do? Would I want to do, like, the 90-degree rule? There's so much different math. Do you have a question, Amira, about math? Yeah, I think the chat's a lot better this time. Last time I was lagging like 30, 40 seconds. Quadrilaterals day 4, spiral number 4. All right. Let's see what we got. Quadrilaterals. All right. Quadrilaterals day 4, spiral number 4. Okay. Is it the one with the pendulum? Ah, Big Red, you've been here a lot. Oh, what's up with my light? There we go. I don't know. Give it a second, it'll go away. I don't know what just happened with my lights. Alright, let me see what I can figure out, Big Red. Let's see. The period of a pendulum is the time required for the pendulum to swing back and forth to complete one cycle. The period in seconds is a function of the pendulum's length, which is defined as the formula. Well, we're missing the formula. That's the issue. We're missing the formula in that problem. So let me go look at the actual original document. Let me get off of my iPad and go to my computer and look at it. Give me a second. Let me get there. I gotta find that formula or we can't solve that problem. And that's probably what your problem is you don't have the formula, therefore it's not solvable with the given information. It's just Microsoft Word does some weird stuff sometimes when you put math in it. That's why I don't use Word. I'm almost there. You got so much running on my computer, so be patient. See, it pulls up on my... Give me a second, guys. I can't see the... The heck? Oh, wrong window. That one. And come on, computer. Okay, let me pop this up so you can actually see the formula. Display capture. So here's the actual problem itself. What you were actually missing was the formula. T equals FL of 2 pi square root of L over 32. Find the exact period of a pendulum in terms of pi when the length is 8. So this is actually pretty straightforward. To find the actual period, let me get off of this. Right there. We're simply going to, if we know that the period, if we know that my length is 8, and we have a formula which is going to be 2 pi times the square root of 8 over 32. This is the L, so I just substitute it in, and then from there we just simplify. So we have 2 pi 8. We can reduce 8 out of 32 to what? 4, 8, 60, 1 over 4. Square root of 1 over 4. Yeah. Square root rules say that you can do the square root on the top and the bottom. So we get 2 pi to the square root of 1 over the square root of 4. 2 pi times square root of 1 is nothing more than 1. Square root of 4 is nothing more than 2. Well, what's half of 2? That's just 1. So I'm just left with pi. So my period is actually just pi. So the exact the period itself in terms of pi is just pi. If you were missing the formula, you couldn't solve this problem. Alright, let me get back over to the chat and see what's going on. I need day 4, number 1 and number 2. What's up, it's your boy? Good point, Chris. I didn't even think about it. I just turn it off, make it easy. Alright, let's see. You need a spiral review, day 4, number 1 and 2. Huh, exact same document I was just on. Hold on, guys. I gotta get this chat where I can see it and work this document at the same time. I'm gonna slide this over to this screen so I can see that there beautifully, and then come over to my stream. All right, it's your boy. So you said day 4 spiral questions 1 and 2, right? I need spiral review day 4, number 1 and number 2. All right. Let me erase and let's get going. Alright, so number 1, as I'm reading it here, says, show that the points with the coordinates of A is, so I've got a point A, which is -3, 4. I have a point B, which is 4, 1, and C, which is -1, -1, that are the vertices of a right triangle. Okay, so we need to figure out if this is a right triangle. Well, you know what? My first instinct is let's graph it and let's see if it doesn't even look like a right triangle. So here we go. So let's do -3, 4. Let's call that A. 4, 1. Let's call this B. -1, -1. So -1, -1. Let's call this C. So it passed the eye test, but we're not real sure. So what we actually need to figure out is are 2 of these legs intersecting that are going to be perpendicular? That's it. Because if any of these legs are intersecting, their angles are perpendicular, it means they're 90 degrees, that means it's a right triangle. So what we need to do is we just need to check the slopes of each of these line segments. So I need the slope of AC. I need the slope, give me some room to work. I need the slope of CB. And then I need the slope of AB. So I want to find the slope of all 3 of these line segments. If I have a negative reciprocal, then this is going to be a right triangle because then those are going to be perpendicular, which forms a 90-degree angle. Now, if you remember, my slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, so from here, let's just plug it in. Let's do AC. So we're going to do negative 1 minus 4 over negative 1 minus a negative 3. This gives me a negative 5. This becomes a plus over 2. All right. So the slope of AC is negative 5 over 2. That works. The slope of CB. So we're going to do negative 1 minus 1 over negative 1 minus 4. All right. Well, negative 1 minus negative 1 is a negative 2 over, let's say, a negative 1 and a negative 4 gives me negative 5. Which this gives me a positive 2/5 because a negative divided by a negative is the same as a negative times a negative, which makes it a positive. I can stop right there. If I look at here, this slope here is a negative 5/2. If I flip this fraction upside down, I'd get 2 over 5. And if I take the opposite sign, the negative becomes a positive. So this is a right triangle because AC and CB are perpendicular, meaning that this is a 90-degree angle, making it a right triangle. All right, so that one's done. And let's do, you said number 2. Give me a second to erase. It's actually a really good question. I hadn't worked all these questions yet because then everything went into chaos. All right, so we want number 2. It says find the exact distance and midpoint between points A and B from the previous question. All right, so my point A is negative 3 comma 4, and B is 4 comma 1. All right, so let's do the distance first. We need to know my distance formula, which is going to be x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And of course, we're going to take the square root of the whole thing. All right, so from here, if you remember, it does not matter which one of these points you pick as 1 or 2. You just got to pick one and just stay with it. So let's just call this x sub 1, y sub 1, x sub 2, y sub 2. Plug it in your formula, spit out a number. Now the key is in this problem, it says exact. So we don't want any decimals. We need to have something in, it's not a perfect square root, it's going to have a square root in the answer itself. So let's just dive in. So let's do 4 minus a negative 3 squared plus, let's see, this is going to be negative 1 minus 4 squared. Of course, we're taking the square root of this whole thing. Let's just do the arithmetic. 4 minus a negative 3 is 7 squared. Negative 1 minus 4 is going to give me a negative 5 squared. And of course, I still need the square root. This gives me 49 plus 25. Take the square root. Let's see, 49 and 25, that's going to give me a 4. 74, square root of 74. Yeah, 74. 74 is not a perfect square, so I need to break it down. So I have 74. I'm going to say how many times does 2 go into 74. It's going to go 37 times, and that's it. That's it. 2 and 37 are prime. So this is your exact answer. You're done right there. So that's done. Now, to find the midpoint, our midpoint, we have a formula, which is our midpoint formula. Just to remind you, we're going to take the average of my x's, so x sub 2 plus x sub 1 divided by 2, and y sub 2 plus y sub 1 divided by 2. All right. So from here, we're just going to plug in what we have. We're going to add up my x's. Negative 3 plus 4 divided by 2, and 4 plus a negative 1. 4 plus a negative 1 divided by 2. Just do the arithmetic. This gives me 1/2, and this gives me 3/2, and there's your midpoint. Pretty straightforward. I'm not going to finish writing it. What other questions you guys got? You guys got any more questions for me? I'm going to solve my Rubik's Cube till y'all figure out a question, and when I'm done, if y'all don't have one, I'm just going to pick a problem and solve it. Can you explain number 1 on clarification station on day 3? Absolutely. See if it's in this one. Probably not. All right, give me a second. Get pulled back up here. Clarification day 3. So number 1, let's see, what is number 1? Okay. So on number 1, we're dealing with a parallelogram. So let me draw in what we have. We have a parallelogram like so. This is M, J, K, L. We have the diagonals here. This is 30 degrees. This is 70 degrees. And we have another diagonal here. And then this is R, 3A, 21, 2B plus 3, and 45. All right, so on A, it says find the angle of MJK. So MJK. So we're looking for this angle right here. With that angle, because this is a parallelogram, it's got properties. We know that these are parallel. These are also congruent. These are parallel. And these are also congruent. All right. Now, within this, we know that opposite sides of a parallelogram are congruent. Congruent just means that they're equal. So all I have to do to find the measure of angle MJK is I just need to, it's going to be the same as the measure of angle MLK. So it's the same as this one right here. It's the same as this whole angle here, which is just 30 plus 70, which gives me 100 degrees. So that's A. It's just knowing the properties of the parallelogram makes your life a little easier. All right, so B, let's see, it says the measure of angle JKL. So the measure of JKL. Well, we know that one of the properties of a parallelogram is any consecutive angles are supplementary. That means if I take this angle plus this angle, they're going to equal 180 degrees. Well, I already know this angle right here is 100. So all I have to do is do 180 minus 100, and that gives me 80 degrees. Not terribly bad. C says the measure of angle JML. All right, so JML. Well, if we know this angle right here, we just found that angle is 80 degrees. The opposite angle, part of the properties of parallelograms, is going to be congruent. So that's just also 80 degrees. All right, D. D says the measure of angle KJL. KJL. All right, so KJL. All right, so here's where it gets a little confusing. There's not really properties of a parallelogram, but this is actually, if you look, you have two parallel lines being cut by a transversal. We did this last semester. And JKL is actually opposite interior angles to MLJ. So this is 30 degrees. So this one is going to be the same angle because they're opposite interior angles. So this is nothing more than 30 degrees. All right, and then let's see. We've got E. E just simply says solve for A. So because these two segments are congruent, congruent leads to an equal sign for algebra. We do this a bunch in class. So we just simply say 3a equals 21. 3a equals 21. Divide by 3. And I get a equals 7. And last but not least is f. F basically asks me to find b. And these opposite sides are congruent. Congruent leads to the equal sign to set up our algebra equation. We have 2b plus 3 equals 45. We're going to subtract 3. We get 2b equals 42. Divide by 2. And b equals 21. Not terribly bad. Not terribly bad. I don't like this green. Y'all probably can't even tell it's green. It's like really a weird glow. Alright, what other questions do you got for me? What other colors? Or what other questions? Do. What am I doing here? Guys, this stream coming through okay? It looks to be fine on my end. Any more questions, folks? No more questions? Y'all just want to see me do math? Alright. If y'all ain't got questions, I don't want to hear y'all crying when I pick a problem. Let's do Beecher. I really need like 5 computer screens legitimately to do this. Let me pick something pretty simple, maybe in chapter 1 in this college book, if I can actually get there. Here's a nice pretty one. You generally kind of get to play with this formula. I want to do something we call the difference quotient, unless y'all ask me a question. The difference quotient, why are my dogs barking? The difference quotient is something that you actually learn when you're taking, should be algebra 2. When I taught pre-cal, I let the kids start playing with it because it's actually, they'll be one step away of doing a derivative by hand. It's pretty straightforward, algebra. So I'm going to do a pretty basic one. So I'm going to tell you that f of x is x squared minus 3x plus 4. And I am going to plug it into my difference quotient, which is f of x plus h, that's an h, minus f of x all over h. Now, I know from calculus that my answer should look something like this when I'm done. There's going to be an h in there. The calculus gets rid of the h, but my answer should have at least a 2x minus 3 in it. That's called a derivative. Super easy to do. All right. So what I'm going to have to do is I'm going to actually plug in x plus h for everywhere there's an x for this first term, and then I'm just going to subtract the entire term here. So here we go. I'm going to have x plus h squared minus 3 times x plus h plus 4 minus x squared minus 3x plus 4 all over h. Piece of cake. That's a perfect square binomial. So that's going to come out to be an x squared plus 2xh plus h squared minus 3x minus h. Where am I at? Plus 4 minus x squared plus 3x minus 4 all over h. Let's see what we get here. This and this cancel as I expected. Here's the negative 3x, positive 3x. Those go away. And then I have my h squared plus 2xh. Oh, the 4's go away. I missed something. Should be 3. Hippity hoppity. Distributive property right there. So this should be a negative 3x and a negative 3h. So minus 3h all over h. These all have a GCF on top, and I'm going to have h over, let's do 2x minus 3 plus h all over h. My h's cancel, which gives me an answer of 2x minus 3, which is what I have here, plus h. The calculus part gets rid of that h. Hey, what's up? I think I fixed my delay in the stream. The delay in the chat. Or at least it should be a lot better now. I actually changed the latency on it. Did some changings on my thing. Yeah, the lag's fixed. That's actually, I don't know how long ago you typed that in, but I think the lag's fixed a lot better. Believe it or not, the way I figured it out is when I typed it in, a video came up of a 12-year-old explaining to me how to do it. Leave it to you kids being able to figure this stuff out before us adults. So chat a little better there. Can I do spiral day 3 question 1? Absolutely I can. You're in algebra 2, right? Let's see. You can do spiral station day 3 question 1. Guys, yeah. Let me pull it up. Where, oh, where is it? There it is. All right, so day 3, spiral day 3. So day 3, spiral, question 1. You know, none of you guys in Algebra 2 asked me any of the fun questions that I put on the problem for you. I don't know if y'all just decided not to do them, or they weren't actually as hard as I anticipated that you thought they would, that I thought they would be. Okay, so day 3, question 1. All right, let's do question 1. Question 1, this actually says solve the below equations to find the solution and extraneous solutions if applicable. And I give you the equation x minus 3 equals the square root of x minus 1. We did this last semester. So the first thing you need to do, we need to get rid of the square root. To get rid of the square root, we need to square both sides. When we square both sides, we have to be conscious to make sure we go back in and check our answers, because we may get an answer that just doesn't work. It doesn't work. It's called an extraneous solution. So we have to check it. But let's square both sides. When I square both sides, this x minus 3 squared, when you FOIL it, becomes x squared minus 6x plus 9 equals x minus 1, because the square root and the square, when you multiply those together, you actually get 1 for an exponent. Here, now we just have a quadratic. We're going to move everything to one side. I'm going to have x squared minus 7x plus 10 equals 0. This factors nicely to x minus 2, x minus 5 equals 0. Set these both equal to 0. This gives me x equals 2 and x equals 5. We're not quite done yet. We have to check for extraneous solutions, so we need to plug it back into my original equation. So we're going to do 2 minus 3 equals the square root of 2 minus 1. Well, 2 minus 3 is a negative 1 equals, well, 2 minus 1 is 1. Square root of 1 is 1. This is an extraneous solution. So this one's extraneous. Let's check 5. We're going to do 5 minus 3 equals the square root of 5 minus 1. This gives me 2. Square root of 4 is 2, so this one's the answer. So only 5 is the answer. 2 does work mathematically when we do this, but that's actually an extraneous solution. What else, guys? What else? What else? What else? Oh, that is peeking out my microphone. Me corner cutting there. I'm sorry, guys. I didn't realize that. Still peeking it out. Any more questions? So, guys, I'm planning on doing this live stream to help. It's not just for you guys, my students, if you're on here actually listening. It's for anybody. So if you have friends that are in a different class, tell them about it. If you have friends if you have a brother or sister that's struggling with math that you can't help them with, tell them about it. Just come and ask me. I'm going to do it at 1 and 5 each day, Monday through Thursday, and then on Friday I'm only going to do it once, so I can kind of have some sort of resemblance of life. But this is actually a lot of fun for me. Other than that, my day's pretty boring. I've been cleaning the house a lot. Pretty boring. Y'all should be helping your parents clean their house, since y'all have a bunch of free time on your hands. Also, there may be some college kids coming on here asking some college level questions that I want to answer for them as well. I'm just trying to help out, because math is not just something you can sit down and figure out on your own. It really isn't. And then I know y'all can watch YouTube videos, and there's Khan Academy out there. I think there's Red Pen, Black Pen. His channel's amazing, but it's way too advanced for high school. Nah, Chris, I ain't doing statistics. So, 1, it takes too long, and 2, I haven't done statistics in like 7 or 8 years, and I am rusty at it. Pretty much everything high school I'll do off the top of my head, and college algebra, pre-calculus, because I I taught my high school pre-cal class like a college pre-cal class, and probably differential calculus off the top of my head. Not all of it, but most of it. Integral calculus, that's where it starts getting tough. Vector calculus starts getting, yeah, I wouldn't even attempt vector calculus. You're talking about where I can refer somebody for statistics help? That'd be great because so many people struggle. In fact, I have a kid that is enrolled in my high school class and also a college statistics class, and she definitely needs help. Everybody with statistics needs help. It's a rare person that doesn't. Well, I think all my kiddos are good with their math. I'm really disappointed that y'all did not ask me any of the fun questions I put in here for you. That is so disappointing. I deliberately put fun questions. Nah, I'm not even going to try to pretend. I'd have to do so much looking into stats again to refresh on it. When I start my master's, man, it's going to be rough when I take master's level, a graduate level stats class, because I'm going to dump a lot of time into that. All right, so I'm going to pull up one of the problems that I gave y'all that I'm disappointed that y'all haven't asked. I think it's on the day 4. It might be day 1. No, I think it's day 4. Day 6, maybe. Oh yeah, no, my fun, not y'all's fun, because y'all know my definition of fun is just working math problems. Y'all's definition of fun is sleeping in my class. Okay, so here's a fun little problem to do. 2x plus 5, this is out of Algebra 2, so if you're in geometry, this is what you get to look forward to. X minus x over x minus 3. But I ain't done. All that is over x squared over x minus 3 minus x plus 1 squared over x plus 3. All right, so this is fun. I don't know why y'all wouldn't think this is fun. This is just awesome. So I'm just going to dive in. I'm going to rewrite this so it actually makes a lot more sense to you guys. I'm probably going to have to erase halfway through this problem because I'm going to run out of space. So actually I wrote that too big. I need to write smaller. So I'm going to have 2x plus 5 over x minus x over x minus 3. I want to put parentheses around it. Then I'm going to divide x squared over x minus 3 minus the x plus 1 squared over x plus 3. Put that in parentheses. So these are the exact same thing. It looks scary. That's all. All right, we're going to get a common denominator. This right here is missing an x minus 3. All right, here we go. So I'm going to have to do 2x plus 5 times x minus 3 minus x squared all over x times x minus 3. And that's going to be divided by, let's see, I'm going to get x squared times x plus 3 minus x plus 1 squared times x minus 3 all over x minus 3 and then x plus 3. All right, I'm going to look for I want to see one thing that cancels. That's a plus. Man. Why'd I do this to y'all? Here we go. I'm just going to distribute everything on top. So I'm going to get 2x squared minus 6x plus 5x minus 15 minus x squared. This is going to be over x times x minus 3. I'm still dividing by. Let's do, this is going to be x cubed plus 3x squared. I've got a minus. This is going to be, man, that is ugly. X squared plus 2x plus 1 times x minus 3. And I'm off my board over here. All over the x minus 3, x plus 3. Okay, so far so good. Let's clean this up. I have 2x squared minus x squared. That gives me x squared minus x minus 15 over x. That's the first one. This next one, I still need to FOIL that. I'm not going to write it on the board, but I do need to write it down so I make sure I get all my terms, because I'm going to have 6 terms here. So, yes, math with pen. X squared plus 2x plus 1 times x minus 3. All right, Jordan, I'll do that. Let me erase this. Yeah, let me help y'all instead of me just having fun. I'll come back and resolve this one on my own. This problem's in your packet anyway, so see what y'all have to look forward to. I hate not finishing a problem though, but all right, so let's see. Jordan, could you do question 3 from Spiral Day 3? I forgot how to do it. So 3 from Spiral 3. Let's see if it's in this packet. Day 1, day 2, day 6. I'm going to write a problem up here that I think the one you're talking about, and then hopefully that's what we're doing. So day 3 from Spiral Station number 3. Yeah, here in a second. Let me do this one for Jordan, and then I will do the other one, okay? So, point-to-point transformations. I forgot I put these on here. Okay, so I give you a point P, which is 4/16. And then I give you a function, f of x equals -2 x minus 1 quantity squared plus 3. All right, and I just basically asked you to go from P to P prime. That's geometry notation, the pre-image to the image. So we need to set up our vector mapping. So I'm going to write my point here. P is going to be 4,16. I'm going to map it to a vector. I want to have an x component and a y component. My x component is what's on the inside, but opposite. So here, because I'm subtracting, I'm going to do x plus 1. And then my y's are just on the outside at face value, so my y vector becomes negative 2y plus 3. And then that's going to map out to my image. So pre-image, image, vector mapping. I just take this 4, plug it in here. 4 plus 1 is 5. And I put the 16 in here. 16 times 2 is negative 32. Plus 3 gives me a negative 29. And you're done. Not terribly bad. All right, so day 1, flip rotation. Problem number 2. Guys, just remember, you can tell anybody that needs math help. I know you guys have friends that aren't my students. Tell them that they can get in here too and ask me questions, because I don't want people to get falling behind because of a microscopic virus. All right, so day 1 flip rotation problem. Day 1 flip rotation number 2. So is the chat better on this stream? Seems to be going faster. All right, so number 2. It's the multiplying one. We're going to find the domain. So we have 3x minus 3x squared all over, let's see, x squared plus 4x minus 4. I've been telling people this is a typo. It doesn't even matter if it's a plus or minus. If it's a plus, it factors. If it's a minus, it doesn't. It doesn't really matter. And then times, I have x squared plus x. I want to actually tell you to make it a plus so we can factor it and not get complex answers and make this all types of crazy, over 3x. All right, so we're going to multiply these multiply these two rational functions together. Not horrible to do. You have to remember, though, we're going to treat this like fractions. You multiply fractions, we're going to multiply straight across. We don't need a common denominator or anything like that, just only when we add and subtract. Before we do anything, though, we want to try to simplify this to make our life simpler. That's why we simplify in math. So we're going to factor everything. We're going to look at each individual, the numerator, denominator, numerator, denominator. We're going to factor it. This 3x minus 3x squared, it's got a 3x. That's your GCF. So we get 3x, and this becomes 1 minus x. This x squared plus 4x, if you change that to a plus, 4x plus 4, that factors to x plus 2 squared. It's a perfect square trinomial. We're going to multiply that. Well, let's see, x squared plus x minus 20. Well, that factors to x plus 5 and x minus 4. Now, guys, we've been factoring for a while now in class. I know you don't do it as fast as me, but I'm not going to go through every single step. We've been doing this for months at this point. And then the bottom is all good at 3x. Now, we're going to look to simplify. So the rule is, when on a fraction, if you look up and down and anything is exactly the same, then it cancels out and becomes the number 1. In this case, I have a 3x on top and a 1 minus x on top, and I have just an x plus 2 squared on bottom, so there's nothing that's the same. Over here, I have an x plus 5 and an x minus 4, and then a 3x on the bottom. Nothing there is the same, so that nothing cancels out. But when we multiply, we're allowed to look at my diagonals here. So I have my x plus 2 squared, and on the other diagonals, x plus 5, x minus 4. Nothing's the same, so nothing cancels. But if we look at this diagonal, I have a 3x and a 3x. This goes away. This becomes a 1. This becomes a 1. So now when I multiply straight across, I'm just going to get 1 minus x times x plus 5, x minus 4, all over x plus 2 squared. Now we want to find the domain of this as well. To find the domain of this, we're going to go back to the step that we're factored. We're going to basically set each denominator equal to 0 and solve to see what number is going to, what number will we put in there? Will we get 0 in the denominator? Because we're not allowed to have 0 in the denominator. So here I can do the x plus 2. I'm going to write cannot equal. It works the same as the equal sign, but it just reminds me that I'm looking for a cannot equal, not an equal. Cannot equal 0. I'm not going to worry about the square because I'm going to take the square root of 0, which is just 0. So I already know that x cannot equal negative 2. And then here I have 3x cannot equal 0. Well, that just means x cannot equal 0. So the domain of this, my domain is going to be the set of all x's such that x is an element of the real numbers and x cannot equal -2 and 0. Done. Pretty easy. All right. What else? What else, guys? What else? What else? What else? Wow, that's 51 minutes already. That flew by. That's flown by. Any more questions, guys? Clarification station number 6 on day 1. All right, let's look. Let's look. All right. So, kind of the same idea. We have a problem where we have x squared minus 6x minus 27 over 2x squared plus 2x divided by x squared minus 14x plus 45. And that's all going to be divided by x squared. Okay. Same idea. Before we even start anything, let's factor everything and see if we can simplify. So let's see, 27, 9 and 3 is going to give me my 6. So this is going to factor to x minus 9, x plus 3. 2x squared and 2x have a GCF of 2x, and that's going to give me 2x, and then that's going to give me a x plus 1 divided by, let's see here, I've got 45 and I need 14, so that's going to be 9 and 5, so that's going to be x minus 9, x minus 5, and then x squared by itself is already fully factored. Okay, so what we're going to do is we also are going to ask for domain. So at this point, I'm going to start building some domain, some numbers that x cannot be, because we got to pay attention to this because of this division symbol. All right, so I don't have to. So right here, I'm going to set each of these equal to 0. Or 2x cannot equal 0, and x plus 1 cannot equal 0. Therefore, we know x cannot equal 0 and -1. Here is also x squared cannot equal 0, which means x just still can't equal 0, so we're good there. But now we're actually going to look, let's see if we can simplify, and then we're going to divide these fractions, which means we're going to have to change division to multiplication. We're going to have to take the reciprocal or flip the second fraction. Then we're going to have to re-look at what other numbers x cannot equal, because we're never allowed to have 0 in the denominator. So looking here, nothing cancels. Looking here, nothing cancels. I'm not looking at the diagonals yet because this is a division, not multiplication. It's only allowed to be multiplication. So now I'm going to change the division to multiplication, and I'm going to take the reciprocal of this. So I'm going to get x minus 9, x plus 3, all over 2x, x plus 1. And we're going to change division to multiplication, and now I have x squared on top, and I have my x minus 9 and my x minus 5. All right, from here, before I do anything else, I'm going to look and see, all right, is there anything new on the bottom that x cannot equal? And it's going to be these numbers here. So I know that x minus 9 cannot equal 0. And then also x minus 5 cannot equal 0 because of the zero product property rule. So now I know that x can also not be 5 and 9. So right here, these are the 4 numbers in this problem that I cannot use at all, because at a certain point you would have a 0 in the denominator. From here, let's just look to see if anything on the diagonals simplify. Here to here, nothing's the same, but here to here, my x minus 9 goes away. If we were actually in class, we would be talking about removable discontinuity in the whole when we start graphing these, but that's, who knows when we're going to get to that. From here, we just multiply straight across. And I'm going to get x squared times x plus 3 all over, let's see, I've got 2x x plus 1 and x minus 5. At this point, guys, I don't really care if you distribute this and clean it up and do all that stuff. Everything I'm really looking to see is, can you change from division to multiplication? Do you know to take the reciprocal? Can you factor, and can you simplify? Can you identify the domain? So the domain on this one is going to be the set of all x's such that x is an element of the real numbers, and x cannot equal these numbers 0, -1, 5, and 9. Done. -2 plus the square root on this one right here. Or 2x squared plus 2x. I would have just factored the GCF out. Is that the part you're talking about? Because everything here factors. No reason to use a quadratic formula. I mean, you could, but you should still get the same answer. All right, so one more problem and then we'll shut the stream down. So I'm going to do number 2, clarification station problem number 4. Which is really along the same idea as this problem. Get something new to erase with. So guys, when I write problems for Algebra 2, to give you a heads up, the one thing that stopped my mom from getting her associate's degree, one of her life goals, was that she couldn't factor. So I kill and drill almost everything in factoring, because it was just, that was the one hurdle she couldn't get over. And I worked at CTC for 2.5 years, and the big thing that a lot of the college kids had issues with was not so much the quadratic formula as it was actually factoring. So that's why I'm so adamant on factoring. And so when I build my problems, I build it off the idea of factoring. So that's why it kind of throws you when it doesn't factor, because I make you factor so much. All right, so you want to do... Oh yeah, there's one of them I have a typo that you probably would have to use a quadratic formula. So yeah, one I had a typo on. All right, so let's do this last one and then we'll shut the stream down. Day 2 clarification station, problem number 4. This problem is going to be x squared plus 3x minus 4 over x squared plus 4x plus 4 times 2x squared plus 4x over x squared minus 4x plus 3. All right, here we go. So same idea. I want you to multiply this rational function. Once you multiply it, we're also going to want to have the domain of this, your actual product. First thing I'm going to do, rational functions. Factor, 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 and then factor again. Factor everything that you can. So x squared plus 3x minus 4, that's going to factor to x plus 4, x minus 1. X squared plus 4x plus 4 factors to x plus 2 squared times, well, let's see, I've got a 2x squared and a 4x. I have a GCF of 2x, and that's going to leave me with an x plus 2. And then on the bottom here, this is going to give me, so this is going to factor to x minus 1, x minus 3. Okay, so before I do anything else, because this is a multiplication, at that point I'm going to take a look at my denominators and figure out what x cannot equal. Just set each of these equal to 0, and we know that x cannot equal a -2, a 1, and a 3. Because if I put a -2 here, I get a 0. If I put 1 here, I get a 0. And if I put a 3 here, I get a 0. So x cannot be those numbers at all. All right, so we're just going to, let's look up and down to see if we can simplify anything. Nothing simplifies here. Nothing simplifies here. Let's look at my diagonals. Right here, an x minus 1 and an x minus 1, they simplify out. They become a 1. On this diagonal here, if you notice, this actually means x plus 2 times x plus 2. That's what the square means. So I have one of them here, and I can get rid of the square, and that becomes a 1. So this simply becomes x plus 4 over x plus 2 times 2x over x minus 3. Now that's simplified down really quick, really pretty. From here, we just multiply straight across, and I'm going to have 2x times x plus 4 over x plus 2, x minus 3. And because it's the last problem, I'll finish this out. We'll do hippity-hoppity distributive property. So this gives me 2x squared plus 8x all over. This is going to be x squared minus x minus 6. And there would be the absolute final answer. Your domain on this is going to be the set of all x's such that x is an element of the real numbers, and x cannot equal these numbers right here, -2, 1, and 3. There you go. Oh yeah, no, that I got you. That's one of those fun problems I put on there for you. I'm sure your aunt actually enjoyed that one when she saw that. She probably laughed. That's just something math people do to non-math people. Because it's fun, at least for us. All right, so I am going to shut the stream down. I will be back up again tomorrow at 1 o'clock. I'm only going to do one stream tomorrow at 1 o'clock. And then I'm going to kind of take it easy, like take the weekend off like I normally kind of do. All right, guys, I will see you tomorrow at 1.